This is Lesson 1 of the NetBackup 7.7 Advanced Administration course, NetBackup Concepts. This is the first lesson in this course. In this lesson, we'll review what makes up a NetBackup environment and describe the overall product architecture. We'll take a look at the different NetBackup administrative interfaces and their function, and we'll review different features designed to help manage NetBackup in an enterprise environment. This is the Understanding the NetBackup Environment topic. We'll begin by reviewing some of the terms that you often hear when working with NetBackup and any data protection product. Two of the key terms in planning for disaster recovery are your recovery objectives, your RPO and your RTO. Your recovery point objective is the amount of data loss that's tolerable in the case of the failure of a server or of an entire data center. None would be nice, of course, but none is expensive. And so a lot of times your RPO is a compromise between the objective you would like to have and the resources that you have available to be able to accomplish this. Your RPO is primarily driven by the frequency with which you protect data. The more often you're able to protect data, the better your recovery point will become. And as you see here on the slide, different backup frequencies and different technologies can improve your recovery point. Daily backups to tape, the real traditional backup strategy, gives you a recovery point of 24 hours, assuming that you're able to offsite that data every day. And that's an important thing to remember about the recovery point, is that there's two things that drive it: how often your backups run and how often you're able to offsite that data and get it to another location in case the main site fails. The old saying always applies in backup and recovery: if there's only one copy of your data, it doesn't exist. So we need to take both of those into account when thinking about recovery point. Our RTO, the recovery time objective, is how long it would take us to restore operations. If this server over here fails, how long will it take me to recover it? If my entire primary production site is knocked out by a natural disaster, how long would it take me to get at least a minimal business capability restored in my recovery site? Your recovery time objective is primarily driven by the technology and the procedures that you use to protect your data. And again, that's reflected on the slide here. You see that the longest recovery time objectives are associated with restore from tape, particularly if my DR strategy is to ship tapes from the production site to a DR site, or possibly even to a vault, which would be a separate location from which I'm actually conducting DR operations. And so in the case of a disaster, tapes would need to be shipped from the vault to the recovery site. That all takes time. And so it's very likely that it'll be days before I have a good operational capability restored. When I am looking to shave some time off of that and get more aggressive recovery time, that's when we start thinking about doing backups to disk. Backups to disk can then incorporate replication, either by using a native SAN-based strategy like Volume Replicator from Veritas, or by using NetBackup features such as AIR. Backups to disk with replication greatly reduce the amount of time that it takes to recover data. Incorporating snapshots into that can also shave off recovery time. The most aggressive recovery time, at least on the slide here, is clustering, which is really drifting away from the topic of backup and restore into the idea of high availability, where I can have an application running on a cluster and there are nodes of this cluster running in different sites. So if an application fails, the application itself can fail over to a node in the cluster at a different physical location, and I can be back online very quickly. I don't know if I can promise you seconds. There will probably take a certain amount of time to restart the application, but you certainly could achieve minutes with a strategy like that. And of course, it's also important to remember that the recovery point and the recovery time may very well be different for different types of data in my environment. I may have enough resources to do, for example, backup to disk with replication for my most critical data, but I may use other strategies for less critical data because of limits on available bandwidth or limits on the budget and what I'm able to afford. A data protection plan outlines the importance of an organization's data and the strategies and procedures used to protect it. How formal a process this is may vary a great deal from organization to organization. In some cases, there may be written service level agreement that specify a particular recovery point and recovery time objective that I'm going to be held to. In other organizations, it can be much less unstructured. One of the things that's most important about this is communication, particularly in environments where this is somewhat less structured. If the backup and recovery planning in my organization is kind of loosey-goosey, it's very important for me as the backup administrator to make sure that I've communicated to managers and stakeholders what my realistic recovery capabilities are. If anything bad ever happens to this server over here, based on the way things are running right now, this is how long it would take me to get up and running again. And if you don't like the number that I just gave you, now is the time to do something about it before there's a problem. So make sure that recovery time and recovery point objectives are clearly documented and clearly communicated. Make sure that your backup strategy is designed to be able to realistically fulfill these objectives. And test often. Certainly at least once per year you should be running a DR drill and making sure that these procedures actually work and that we've got kind of worked out all of the kinks. This slide looks at the different components that makes up a NetBackup environment. From NetBackup's point of view, it all kind of begins with the master server. Every NetBackup environment has at least one master server, and from the software point of view, the master server is the boss. The master server runs the scheduler, decides when backup jobs are going to run. The master server is the primary point of configuration. Almost all the time in the NetBackup admin console, when you're making changes, you're talking directly to the master server. All of the record keeping, the NetBackup catalogs and databases are all located on the master server, about the backup policies I've configured and about the media that I'm managing. The master server is controlling the other servers, the other backup servers in the environment and issuing instructions. And so the master server is key. If the master server is not available, backups and restores are not possible. The media servers are the data mover for NetBackup. When backup jobs run, it is the media server that reaches out to the clients and backs up their data and sends it to tape or to disk to be protected. Media servers don't make a lot of decisions on their own. They don't keep a lot of data locally. Media servers do what the master tells them to do. Every NetBackup master server is also a media server, and so the capability to act as a data mover and protect data is organic to a master server. Whether or not the master server is actually used in that capability will depend on your environment. Small remote offices may have a single NetBackup server, perhaps an appliance, which is functioning as both a master server and a media server and protecting all the data in that office. Larger environments will tend to have multiple media servers doing the actual data movement, and their actions are all controlled and coordinated by a master server, which is not itself running any backup jobs. It's just doing all the record keeping and the scheduling, which in a busy backup environment can certainly be a full-time job for a very powerful server class machine. It all depends on the amount of data that we're protecting. NetBackup clients are the actual file servers and database servers and mail servers, in my environment whose data is being protected. Any physical server that's being protected by NetBackup has a NetBackup client software running on it. We mentioned that every NetBackup environment has at least one master server, and that the master server really controls all the backup operations in that environment. You may have multiple master servers, and so each master server is in charge of running its own backup environment, which NetBackup internally refers to as a NetBackup domain. Whenever you hear that term, a domain is a NetBackup master server and all of the backup servers that it controls and all of the clients whose data it protects. Now, don't get confused between a NetBackup domain and a Windows domain, because there is no relationship at all between the two. NetBackup essentially ignores Windows domains for its purposes. And so that's why some folks will choose to use the term NetBackup environment or NetBackup Empire, some folks may call it. But you may hear the term NetBackup Domain in our documentation and tech notes, and so it's an important term to be familiar with. This slide here illustrates two NetBackup domains, and it's important to understand that they are completely separate from each other. Master servers do not communicate with each other directly about what they're doing. If they have their own media servers they're controlling, they have their own clients whose data they're protecting, and they're keeping their own individual separate records about it. If I have an environment with two master servers, I do not have one monster central catalog somewhere tracking everything, nor would I really want such a thing. In fact, one of the reasons why folks will sometimes split things up into multiple master servers is because the amount of data they're protecting is too massive for one master server to be able to handle without excessive load on the server or excessive catalog size or both. So it might be a performance-based objective. It might be a regulatory or compliance thing. Maybe different kinds of data has different auditing requirements, and I want to keep them completely separate from each other, so when the auditors come, I can direct them to one environment and not necessarily to all of them. That might accomplish a goal for me. Maybe they're different physical locations. Maybe I've got an office in my New York data center and an office in my New Jersey data center, and I've given them each their own master server so that they can conduct operations completely autonomously from each other with no dependency. There's a number of reasons why you might have a setup like this. When you open the NetBackup Administration Console, you're going to choose which master server you want to manage. Now, also illustrated on this slide is OpsCenter. OpsCenter is a web-based tool for doing monitoring and reporting of NetBackup, and it has the capability to collect information from multiple NetBackup domains. And that can be a very useful tool as an administrator if you're responsible for multiple NetBackup domains for your day-to-day reporting and information gathering. You can turn to OpsCenter and view it all in a single pane of glass. OpsCenter is an optional component for NetBackup. The basic functionality doesn't involve any extra cost or anything, although there is an enhanced license available. It does mean that I have set up an OpsCenter server somewhere to collect information from my master servers. In a small backup environment, it's possible that the OpsCenter server and the master server are co-located on the same host. It's not really recommended to do that. There's a fair amount of processing that goes on in an OpsCenter server, so it's better to have it on its own host, especially if you're managing multiple masters. You really want to have a dedicated server for OpsCenter. And so I'll connect to that server with a supported web browser. I'll be able to do monitoring and reporting on both NetBackup domains, illustrated here. And primarily, we're talking about monitoring and reporting. OpsCenter is definitely not a replacement for the administration console. It's more about gathering information. There are some management type tasks that I can do from there. I can up and down tape drives from there. I can do restores from OpsCenter. But it's very much geared around operations, like the name implies, and not so much about administration. NetBackup policies. On the slide here, we see they're the heart and soul of NetBackup, or the bread and butter of NetBackup. Policies are created and stored on the NetBackup master server, and they contain all of the important information about my automatically scheduled backups, what kind of backup it's going to be, and how often it's going to run, and which servers are going to be protected, and which data is going to be included in it. All of this is controlled by NetBackup policies, all centrally located on the master server. NetBackup stores relatively little data on the clients themselves. All of the important information about your regular backups is stored in the policies on the master server. NetBackup policies contain schedules, and the schedules determine when backups run and what kind of backups are going to run. As you can see on the slide here, we can break up the different schedule types in NetBackup into two broad categories, automatic backups and user backups. Automatic backups are scheduled by the NetBackup scheduler and run without manual intervention. And so this could be a full backup, which protects all of the data on the backup selections list every time it runs. Or it could be an incremental backup, which backs up only files which have changed. Differential incremental backs up everything that has changed since the last full or the last diff. A cumulative incremental backs up everything that has changed since the last full. Most of the schedules in a typical backup environment will be of the automatic type. And these schedules can be run manually by the administrator on the master server in order to resubmit a failed job, for example, but most of the time they'll be running automatically by the NetBackup scheduler. The second category of schedules are user backups, which are done from a client system. And in that respect, perhaps a more accurate way of describing these is client-requested backups, because these must be invoked from the client system. They can't be invoked from the master. User backups and user archives are very similar. User backup backs up all the files that are requested when it runs. A user archive backs up the requested data, and then when the backup is successful, it deletes it from the client system. That can be useful, for example, for an application that creates a lot of log files, where you want to periodically archive off those logs and then delete them to free up disk space. You'll notice under User it also says Applications. The user backup functionality within NetBackup is used extensively by some of our database agents to protect data, something which we'll examine in more detail later in this course. When backups of a client take place, we say that NetBackup has created a backup image. An image is all the data that was protected by a particular backup job in Unix tar format, and it can be sent to one of several backup storage types. It can go to removable media, i.e. tapes. It can go to the cloud, to a cloud service provider that NetBackup supports, or it can go to a disk location. And as we'll explore throughout this course, there are a number of different kinds of disk backup which NetBackup supports. Could be a simple SAN disk. It could be a backup appliance. When discussing NetBackup storage concepts, it's helpful to be familiar with some of the terminology that NetBackup uses, because some of it is used in a very specific way. When we say a storage device, we're talking about a physical tape or disk device that actually writes the data that's being backed up. Now, NetBackup policies don't really target specific individual storage devices. They target storage units. Storage units are the destination that backup policies send data to, and a storage unit is basically two things put together. It is a NetBackup media server and a storage device. So, for example, a storage unit, a media manager storage unit that does backups to tape, has a NetBackup media server and a tape library. A disk-based storage unit will reference a NetBackup media server and a disk path, or a pool of disks. A storage unit group allows us to group multiple storage units together to be a single destination for backups. And I might do that for a number of reasons. For example, I might do it simply to extend my capacity. If I have two tape libraries in the same data center and I want to group them together so I can have one policy write data to any available tape drive, a storage unit group is a good way to do that. Each of the tape libraries will be a storage unit, and then I'll group them together. Maybe I'm looking to use my devices in a different way. Maybe I'm looking for some failover capability where I do backups to disk, but I want to give myself a plan B. If the disk ever fills up or fails or something else bad happens, my plan B is to do backups to tape. And so I create a storage unit group with a failover setting where the primary destination is a disk storage unit, but the secondary destination is a media manager storage unit going to tape. So there's a lot of flexibility that you can add to your environment using storage unit groups. Load balancing or failover are possible. A storage lifecycle policy is even more sophisticated than this. A storage lifecycle policy is a complete storage plan for your data that will include the initial backup operation and one or more secondary actions, such as duplication or replication. Storage lifecycles are heavily used in some of the advanced features that we'll discuss in this training, such as auto-image replication. There are two types of storage units in NetBackup which do backup to tape. The most common is the Media Manager storage unit, and the name comes from the fact that a Media Manager storage unit is traditionally used for any kind of storage device which uses removable media, which in days gone by used to mean tape or optical disc. Pretty much all of these optical disc devices have kind of gone the way of the dinosaur, and so these days when we talk about Media Manager storage units, we're talking about backups to tape. Most commonly, a Media Manager storage unit will target a specific robotic tape library, although you can also have a grouping of standalone tape drives of the same density that are configured as a Media Manager storage unit. Another type of storage unit which might do backups to tape is an NDMP storage unit. NDMP stands for Network Data Management Protocol, and it typically refers to an intelligent device such as a filer, which can send data using the NDMP protocol directly to the tape library. In a local NDMP backup, the filer sends its data directly across the SAN to the tape library, avoiding the need to go through a NetBackup media server or to traverse the LAN. When you have a large environment doing backup to tape, the trend these days, rather than having each media server have its own smaller tape library, is to have one larger tape library with multiple media servers that are zoned to it across the SAN and are sharing the tape drives inside it. In NetBackup, this is referred to as SSO, the shared storage option. And so in this case, I have a central tape library with 6 tape drives and 2 NetBackup media servers that are going to be writing backups to this library. So rather than split this up somehow, like give 3 drives to one media server and 3 drives to the other media server, I want to be a little more efficient than that. I want both of my media servers to have access to all the tape drives if they need them. And so the shared storage option allows this. Tape drives are easily shareable devices, and it is the responsibility of the NetBackup master server to be the traffic cop, to assign these resources intelligently, and to make sure that nothing silly happens like media servers fighting over tape drives or anything like that. The master server does not require SAN connectivity to the library in order to fulfill this function as the media manager, although if it does have connectivity to the tape library, that allows the master server to control the robot itself. And when we say control the robot, the device we're really talking about here is the medium changer, the picker inside the library that mounts and unmounts the tapes. The medium changer is not a shareable device. Only one server can control the medium changer, unlike the tape drives themselves, which can be shared. And so it is common in an environment such as the one depicted on this slide to have the master server controlling the robot and the changer, and then the media servers that are actually writing the backup jobs share the tape drives. And my goal here is to consolidate my points of failure. If the server that controls the robot itself fails, I'm not going to be able to do backups or restores to this library unless I reconfigure my devices. And so my thinking here is that's a great job for the master server, because if anything bad ever happens to the master, I'm not going to be able to do any backups or restores anyway until it comes back online. And it's really not a lot of work to fulfill this function, so I don't need to worry about that, overloading my master or anything like that. A volume is NetBackup's term for a single piece of removable media. Each tape in your environment is a volume, and each volume is assigned a unique media ID, which is tracked in the NetBackup database on the master server. Volumes in NetBackup are organized into volume pools, which is a collection of tapes that are used for a specific purpose. The function of volume pools is to make the physical management of your tape media easier. And so this slide shows the default volume pools that are created upon installation of NetBackup. The NetBackup volume pool is the default volume pool. If you do nothing else, all your tapes will be members of this pool. The data store is a set of tapes that's used for third-party add-ons to NetBackup. For example, if you have Enterprise Vault exporting data to NetBackup for tape out, it'll use a data store volume pool. Catalog backup are your catalog tapes. When you're doing catalog backups to tape, NetBackup always has you put these tapes in a separate volume pool because they're critical for disaster recovery. And the non-volume pool is a special pool. It's a pool of tapes for which backups are never written to. And so your cleaning tapes go into the non-volume pool. You never want to try to write any data to them. And if there were ever any other tapes in the library where you wanted to say, hands off NetBackup, don't ever write any data to them, you could make them part of the non-volume pool. Otherwise, NetBackup is going to assume that it owns all the tapes in the tape library. And so those are the default pools, and you could run your whole NetBackup environment just using the NetBackup volume pool for backups if you wanted to. But most folks who have a lot of tapes in their environment have a need to have some separation of data. For example, I want all my mail server backups on different tapes than my file server backups. Or I want my monthly full backups on different tapes than my weekly incremental backups. Again, the physical management of tapes is usually what drives these sorts of requirements. And so I'll create different volume pools for different purposes. If I want my file server backups separate from my mail server backups, I'll create different volume pools for the different types of data. The use of a scratch pool is optional. The scratch pool is a reserve of tapes. If you run out of tapes in any of your other volume pools, NetBackup can automatically grab one from scratch. And that can add a lot of resilience to your environment. It makes it harder to have backup jobs fail because of out-of-media errors. Large tape-based environments will oftentimes configure NetBackup so that all new tapes are placed in the scratch pool. And then any volume pool that needs one can just automatically grab one from scratch. And that's a very common, very useful thing to do. Do note, however, that the scratch pool is not configured by default. It's something that you do, if you want it, when you first configure NetBackup. Doing backups to disk rather than to tape is an increasingly popular backup strategy, and NetBackup has very robust support for backup to disk. And there are a number of different kinds of disk storage units that I can configure in my backup environment. The simplest of these is the basic disk storage unit, in which case we're talking about individual disks here, or at least individual disk volumes, and each volume is configured as its own storage unit. So if I had 3 drives that I was using as a target for backups, then I would have 3 basic disk storage units configured. So basic disk is very easy to set up. It supports disk staging, which is a form of automatic duplication of backups to another location, such as tape. There's no additional cost or licenses associated with it, but like the name implies, it is very basic. It doesn't support advanced features like AIR or storage lifecycle policies, and there are issues you can run into with scalability with basic disk. Suppose the storage team provisions 25 volumes for me to use for my backups. I would then need to create 25 storage units in NetBackup and manage the capacity of them individually, and that makes administration more complex and unwieldy. I can use storage unit groups, and that'll help me out a little bit, but it still, becomes cumbersome. And so that's where disk pools come into play. The last 3 types of storage units referenced on the slide here are different types of disk pools, and in a disk pool I have 1 or more disk volumes that I have pooled together to be a single destination for backups. And so looking at the next example, advanced disk, let's say I've taken those 25 volumes the storage team provisioned for me, and I created 1 advanced disk pool. Now I treat that pool as a single storage unit in NetBackup. And I say, here you go, NetBackup. I've got this pool of disks that I have configured as an advanced disk storage unit. And tonight we're going to be backing up a couple hundred gigabytes of data. And I'm going to send them to this disk pool. And I want you to do something smart with them. You manage the capacity. You manage the load balancing. Be intelligent about the way you allocate space on these disks. Span if necessary, but don't do it if you don't have to. These are all intelligence that's built into disk pools and advanced disk storage units. so that instead of having to worry about managing each individual disk volume, all I need to manage as a NetBackup administrator is the capacity of the pool as a whole. Do I have enough overall space for tonight's backups? And I don't want to have to worry about which particular spindle a particular backup job is going to. And I also have support in Advanced Disk for load balancing storage unit groups, and support for storage lifecycle policies. So I have more advanced features that are associated with Advanced Disk. The one really important advanced feature that Basic Disk and Advanced Disk don't support is deduplication, the elimination of redundant storage from disk, which is a big trend in the industry. I do see support for deduplication in Pure Disk, and I often see it in Open Storage. Let me talk about Pure Disk first. Pure Disk is Veritas's deduplication solution for NetBackup, and it's called Pure Disk because this was originally a whole separate product that Veritas offered that was compatible with NetBackup, that was eventually folded into the product, so that Pure Disk services now run natively on NetBackup media servers. And so Pure Disk storage units are associated with media server deduplication pools, or MSDPs. When using deduplication with an MSDP, unique data is written to the disk pool only once, which means that I can store a lot of data with a lot less disk capacity, and in many cases I can have longer retention periods on disk than were possible before. So deduplication is a key enabler for disk-based backups. MSDPs may be created using fast-performing disks such as SAN disks on any NetBackup media server, or another common way of using MSDPs is NetBackup Appliances. NetBackup Appliances tend to offer better performance and significantly larger capacity than build-it-yourself MSDP pools. Open Storage, which was the third row here on the slide, Open Storage is really an API which the NetBackup Master Server supports, which allows third-party non-Veritas vendors to have disk appliances which communicate with the NetBackup Master Server and have access to some of NetBackup's functionality. The big thing here is, we've seen a lot of vendors making backup appliances that have features such as replication that they could be conducting and NetBackup might not be aware of. You back up some data to a VTL, the VTL replicates the data halfway across the world to some other VTL, now you have 2 copies of it, and that's great, but NetBackup only knows about one of them. That was the problem that we were facing. With OST, you can back up your data to a supported virtual tape library or disk appliance, and then the appliance can do something like replicate the data somewhere else, and then inform NetBackup, hey, look what I just did. I just made another copy of the data, so that records are maintained of this in the NetBackup Master Server, and you have a single point of control for all of your backup data, which is what you want. OST devices also have access to some of NetBackup's features, such as AIR, or NetBackup Accelerator. Which particular features a third-party OST device might or might not support is documented in a NetBackup Hardware Compatibility Guide. And so that's a very key piece of documentation if you're working with third-party appliances, because it outlines exactly what they do and what they don't do. NetBackup appliances, of course, support all the features that are in NetBackup. Appliances from other vendors, they pick and choose, okay, my appliance is going to do this and not that. So make sure you check the HCL to see exactly which functions a particular appliance supports. This slide describes some of the disk terminology that's used in NetBackup, some of which is industry standard you're probably already familiar with, and some of which is unique to NetBackup. And so when we talk about a disk enclosure, we're talking about a device that presents disks or disk volumes to NetBackup servers. Now this might be something very simple as a JBOD, just a bunch of disks, or it might be something very sophisticated like a high-end array, or possibly a purpose-built backup appliance. It can vary. But this enclosure is going to present either disks or disk volumes to NetBackup to use as a target for backup storage. In the example that we're looking at here, it's presenting disk volumes, and so there's probably some kind of RAID going on in the background by the enclosure. Now, NetBackup has taken some of these disk volumes, looks like 2 in this example, and pooled them together into a disk pool. And again, the disk pool will be a single destination for backups. So any disks that I pool together get set up as one storage unit in NetBackup. And in this example here, this looks like an example of an advanced disk pool, because we see that there's a NetBackup media server that is zoned to this enclosure, probably across the SAN. And then we see that this media server is acting as the storage server. The storage server is a NetBackup specific term. It refers to the server that really owns and controls these disks. Also, the storage server ultimately writes the data to these disks. In the case of advanced disk, we see one host that's providing both functions. It's a media server and a storage server. So it's the data mover that copies the data from the clients, and it sends it to these disks in the disk pool that it is basically controlling. Now, in other implementations of disk pools, the storage server may not be the media server. In the case of a backup appliance, for example, the appliance itself may be the storage server. That's what happens during OST, which you'll notice is kind of called out on the slide here. When you use a third-party device like a data domain appliance, for example, with NetBackup, and you're using OST, then the NetBackup media server gets an OST plugin installed on it, and the NetBackup processes on the media server hand over the data to this plugin via the OST interface. And then from that point, the vendor's plugin is responsible for writing the data to the appliance. And so in that situation, the appliance is the storage server that's controlling the disks and writing the data. The media server is a separate host that's copying the data from the client and handing it off to the OST plugin. Whenever you use disk pools in NetBackup, there will always be a media server. There will always be a storage server. Sometimes it'll be the same host and sometimes it won't be. It's specific to the type of disk pool you're using. Here's another example of a topology where we're doing backups to disk. In this case, we're doing backups using NetBackup Appliances. Now, NetBackup Appliances are unique compared to other vendors' backup appliances because they incorporate a NetBackup server in addition to a disk shelf, one or more shelves, that's used for storage. And so in the case of NetBackup Appliances, the appliance itself will be acting as a media server, possibly also as a master server, depending on the appliance model and how it's been configured. And it'll be writing backups to its own disk shelves or to tape out. In this case, it looks like it's going to disk. And so we have an MSDP disk pool configured in the appliance, and the appliance is acting as both the media server and the storage server. Now, this means that the appliance could function completely as an all-in-one solution, or if you had a lot of data that you were protecting and you were concerned about the ingest rate of the appliance, you thought that there was going to be a lot of work going on processing all of this deduplication, you could use additional servers as load balancing media servers. Any Veritas MSDP pool can do this, whether it's an appliance-based pool or a build-it-yourself pool. And load balancing media servers can be appliances themselves, or they can be build-it-yourself media servers. So in this example here, the appliance is the storage server that's hosting the MSDP pool. An additional build-it-yourself media server has been added, has been credentialed to this pool for load balancing purposes to help out with the deduplication. Here we have an example here where we're using a third-party OST vendor, a non-Veritas appliance. And so in that case, we're using OpenStorage, OST, and the NetBackup media server is the data mover, copying data from the client. And then once it has the data from the client internally on the NetBackup server, the data is handed off from the NetBackup services to the OST plugin. This is a vendor-provided plugin which has been installed on the NetBackup media server. So NetBackup hands off the data to this plugin. The plugin is responsible for sending the data to the appliance. That might be a SAN or a LAN transmission, depending upon how it's configured. And so in this example over here, the OpenStorage appliance is the disk pool and the enclosure. it is also the storage server. And so this is a good example of when in a NetBackup environment the storage server and the media server would not be the same host or appliance. NetBackup catalogs are maintained on the master server, and they contain all of the critical information about your backup environment. These catalogs are separated into two distinct categories. The NetBackup database is a Sybase relational database that contains media manager information about devices and tapes in your environment, as well as other data such as the headers for your backup images and some data that's used for database agent cross-checks and other data, a lot of which used to be in older versions of NetBackup stored as flat files. But with every version of NetBackup, we've seen more and more data kind of migrate from flat files to the relational database. You know, the big thing is any kind of catalog content that would benefit from the more robust indexing capabilities that a relational database brings to the table is the kind of data that we've seen migrating over time. So the NBDB is the relational database. The configuration files are flat files which contain other important information. The largest and most significant of that is the image catalog, which contains the lists of all of the files that have been protected. And the NetBackup configuration files, although they are flat files and not a database, actually make up the largest percentage of the catalog space on a master server. And that's all because of the image catalog. The image catalog is really spread between these two categories. Like I mentioned earlier, the image header, which is a pretty small amount of information, is stored in the NBDB. The file lists, the actual records of every file that's backed up in the backup image and the complete path where it came from, that's stored as a compressed file in the NetBackup configuration files. And so if I were to go to create a backup image that had 1 million files in it, I would have one small entry in the NBDB, and I would have the records for 1 million paths, 1 million entries in this flat file catalog. Here's an overview of the data backup process in NetBackup. The NetBackup policies on the master server control everything that happens during an automatically scheduled backup. And so according to the start windows in the schedules contained in the policy, the NetBackup scheduler will determine when jobs are run, and the NetBackup master server will instruct the media server to reach out to the client, copy its data, and send it to the destination, either to tape or to disk. Records are kept in the master server of successful backups for calculating the next time the backup should run if it's a frequency-based backups, and reports and log files are generated showing the status of backups. In a restore, a request is made by a user or an administrator to restore files. The user or the administrator browses the available files from the catalogs on the NetBackup master server using the bar interface, and then based on the selections that they have made, the master server instructs the appropriate media server to mount the tape or disk that's required for the backup, read the files, and then send them to the target client. As the restore is in progress, log files are generated which can be monitored by administrators and users, showing the process of the restore. This is the Using NetBackup Administrative Interfaces topic. The NetBackup Administration Console is the main point of management and configuration for NetBackup. Note that in version 7.7 and later of NetBackup, there is only a single Administration Console version, the Java console, for all supported NetBackup platforms. The Administration Console is broken up into two views. On the left-hand side, the Object Tree area is where you can select objects, and based on the object that you've selected in the Object Tree area, details and tasks will appear on the right-hand side in the Details pane. Here's an example of the NetBackup Administration Console with the Activity Monitor selected in the left-hand tree view. The Activity Monitor is perhaps the part of the admin console that we spend the most time looking at. How am I doing in terms of my backup and restore jobs? What has been successful and what has not? I can see the past 72 hours worth of activity here by default. And so primarily we're looking at backup jobs, but you'll notice down at the bottom that there are 3 tabs to the activity monitor. I can view jobs, daemons, and processes from here. Moving further down the tree on the left-hand side, we come to the host properties, which is where many of the most important options and settings are for NetBackup. Every type of server, master server, media server, and clients in NetBackup has host properties, and so when you want to make a change to NetBackup's default behavior, this is oftentimes the first place you'll look, and where you go depends upon the kind of change you want to make. If I wanted to make a change to one specific client, for example, to switch between using archive bits or mtime for incremental backups on a Windows client, I would go to that client's properties. If I wanted to make a global change, which affected everybody in the environment, I would typically go to the master server. And that's what you can see here. This is the master server host properties, global attributes, and these are settings such as the job retry delay or the maximum jobs per client, which will affect everyone in my environment if changed. This slide shows the location of the NetBackup binaries and executables. This is particularly important information for anyone who's going to be doing any command line administration in NetBackup, and you almost always wind up occasionally reaching for the command line when you do NetBackup administration. So these directories are where you'll find the NetBackup binaries and executables. If you would like to set up your path environment variable on your NetBackup servers so that these paths are included, that will save you from having to worry about which directory you're in when you go to run a NetBackup command. And then you'll notice the last bullet point at this slide shows where you can get some help. On Unix-based systems, there are man pages available for the most common NetBackup binaries. For both Unix and Windows, the NetBackup Command Reference Guide is an excellent summary which lists all of the NetBackup commands and all of their switches and options, which is a terrific resource, again, for any NetBackup platform. This slide shows an example of the OpsCenter interface. OpsCenter is a web-based tool that can monitor and report on one or more NetBackup master servers. OpsCenters can be very useful when you have multiple master servers that you're responsible for. The NetBackup Administration Console can only monitor one master at a time, whereas OpsCenter can monitor multiple masters. As you see here, there's 2 different master servers that are connected to this OpsCenter server. We could be having one OpsCenter server collect information from a much larger number of masters if we needed to, and we could group them together geographically to help with the organization. And then we could run reports against either individual masters or groups of masters. So as your environment scales larger, this tool becomes very useful. Honestly, even a small NetBackup environment with a single master server benefits from this, because the reporting that's available from OpsCenter is much more robust and configurable than what's available in those very basic reports in the NetBackup Administration Console. Now, as you can see from the bullet points on the slide, an OpsCenter server is a separate installation from NetBackup. You could put this on, a NetBackup media server, for example, but we generally recommend using a standalone server just because there's a fair amount of processing that goes on an OpsCenter server, particularly if you're monitoring more than one masters. You really should use a dedicated host. Could be a physical or a virtual host. Multiple platform types are supported. Windows generally tends to give the snappiest performance. That's because it's a Sybase database, and Sybase is a little snappier on Windows than it is on Unix or Linux. There's no mandatory license for using OpsCenter. Most of the functionality is available free of charge. There is an OpsCenter Analytics license, which will enhance the functionality of OpsCenter in terms of giving you a longer reporting history. The default is 60 days without analytics, and in allowing you to generate your own custom reports from scratch, whereas with basic OpsCenter, you're limited to the reports that are supplied with the product. This slide shows a very specific breakdown of what's added to OpsCenter with the analytics license. And so OpsCenter normally has operational reports, whereas analytics adds business level reporting, specifically chargeback reports. and also includes the ability to build your own reports from scratch using either a graphical interface or by writing your own SQL. There's a copy of the database schema that's included with OpsCenter Analytics to let you write your own totally custom reports, which is potentially a very powerful reporting tool. OpsCenter normally keeps reporting data for up to 60 days, or with Analytics, that becomes an unlimited amount of time. Analytics is a licensed option if you're using traditional NetBackup licensing. If you're using platform-based licensing, it's included. And so you'll find when you use it that the majority of OpsCenter's functionality is included with the basic license, but you get some very compelling options if you add in Analytics. This is the Using NetBackup in an Enterprise Environment topic. NetBackup integrates well into enterprise customer environments for a number of reasons, but particularly because of its flexibility, its scalability, and of its security, all of which are top concerns in a large enterprise. This course will focus on features and functionality that assist in these concerns, including backing up enterprise applications, tuning NetBackup performance, securing backup data, and much more. This slide shows different NetBackup policy types. And as you can see from the columns marked with an asterisk, standard file system backups, standard and Windows policies on physical servers, VMware policies on virtual servers are covered in a fair amount of detail in the NetBackup Administration course, which hopefully all of you have taken prior to this training or have equivalent real-world life experience. NetBackup catalog policies, preparing for disaster recovery, are also covered in quite a bit of detail in that course. In this course, the advanced course, we'll spend some time talking about other policy types which really don't get a lot of coverage in the basic administration course, in particular focusing on databases such as SQL Server and Oracle, and on enterprise applications such as Exchange and SharePoint. Not all of the policy types listed on this slide will be discussed in detail in this course, but a lot of the knowledge is transferable. Once you get a good grip on how to back up databases using NetBackup for SQL Server and NetBackup for Oracle, for example, using the techniques discussed in this course, you'll be able to apply that knowledge for other NetBackup database types. As we go through this training, you'll frequently hear me refer to NetBackup Appliances. NetBackup Appliances are custom hardware offerings from Veritas that incorporate a NetBackup server and one or more disk shelves. NetBackup Appliances belong to a category of hardware called PBBAs, or Purpose-Built Backup Appliances. And this is more than just NetBackup pre-installed on a specific set of hardware. This is a complete hardware and software package that's optimized for backups. And so as you can see inside a NetBackup appliance, we have the NetBackup software, of course, running along with deduplication. We have Veritas Storage Foundation, providing for easy online reconfiguration. We have a hardened operating system, which is designed to resist intrusion and provide high security. We have hardware that's been optimized for backup performance and redundant storage through the use of RAID 6. Built-in WAN optimization, and semantic critical system protection, which is part of the kernel-level hardening that takes place. And so the big thing about appliances is that they're easy to deploy. I skipped the whole installation step and the whole integration step and the whole upgrading and tuning step. All of that has been done for me. The software comes pre-installed. There's a relatively brief configuration where I personalize it for my environment. It takes about 20 minutes or so, and then I'm up and running and ready to go. And then when upgrades come out, I'm going to have single patch updates. So the operating system, the hardware firmware, the NetBackup software, all gets updated by a single patch. I don't have to manage them all individually, and I don't have to worry about compatibility issues because that's all been tested for me. Veritas has already made sure that if there's a change to the NetBackup software, a change to the underlying operating system, that they're going to be compatible with each other, and that's not something I have to worry about. So there's a significant time savings, which translates directly into reduced administration on my part, and that translates directly into reduced cost. It also means that it's a single vendor solution, a true single vendor solution, and so I get support from a single source. Whether it's hardware or software issues, Veritas is here to help me out. There are two major appliance models that are available from Veritas, the 5200 series and the 5300 series. And the most recent ones are shown on the slide here. The 5230 has a NetBackup server integrated into it, which can be configured as either a master server or a media server, or both. You could run an entire backup environment just with a single appliance, or you could have an appliance master controlling multiple media server appliances. You can mix and match appliance and bring your own servers. So you could have a master server appliance that's controlling NetBackup servers you built yourself, or vice versa. And then the 5330, which is kind of a larger scale appliance, is available in media server configuration only. That has an integrated NetBackup media server and considerably more capacity, considerably more density in terms of the amount of storage per rack space unit, and considerably higher performance than the 5230. These things really eat data. This slide shows some sample appliance offerings, and this is by no means all of them. By adding additional disk shelves to an appliance, you can increase the storage capacity, and so there's a lot of flexibility in terms of the size of your appliance, ranging from a small remote office all the way up to a large enterprise. And so we've just picked a sample of them here to show how it can scale to suit your needs, ranging from the smallest possible offering, which would be a 4 terabyte 5230, so there's no disk shelves being used there, just internal storage on the appliance head unit, or that 5230, by adding disk shelves, can scale up to 144 terabytes of usable capacity. Or if we look at the 5330, we could go up to 229 terabytes of usable capacity. If you're interested in more information about NetBackup Appliances, there is a 2-day appliance administration course available from Veritas Education, which goes into the setup, administration, and management of appliances in considerably more detail. In this lesson, we reviewed the NetBackup environment, including identifying common NetBackup components and their functions. We reviewed the NetBackup administrative interfaces, and we discussed how NetBackup enhances flexibility, scalability, and security. This concludes Lesson 1.